All right, we are live. Hi everyone, I am really excited to interview Theodore Galanos, senior researcher at AIT. Theodore is pioneering in ACAI development and is pushing, I feel it, he's pushing the boundary with his amazing work. And I'm glad to have you back on the show. It has been more than 1.5 years.
Yeah, yeah, it's great to be back. Thanks for having me. Hopefully this time with proper sound on my side. Yeah.
So, Theodore, can you share some highlights of the projects you did in last 2 years?
Yeah, sure. I mean, in terms of AI and design, like the two major things, or like the major project has been infrared, which was sort of the instigator, at least for me, like the reason why I went towards AI, mostly to try to understand how I can bypass certain issues that performance-based design has, or at least I was facing at my work. So I was trying to do a lot of complex stuff, and they just took way too much time, too much stress, too many, too much cost, and at the end had very minimal impact. So I was really disappointed, even though I knew that these studies had were really cool, like really important. You could really design around them, but I could never do, like the project could never do. So that was infrared. Infrared was like a question if we can do this much faster uh, and differently, if we can predict it instead of simulate it, and that's infrared. It was a shot in the dark in the beginning, but it turned out it worked. So, and this is like a trend I think in the stuff I've done the last 3 years. There's been a lot of shots in the dark. Like some of them work, right? But there is also a lot of sort of misses, which is good. But yeah, if you they usually lead you to something better. So infrared worked. Like now, it's going actually in production. Like it's a real tool. It's like a platform. And the thing that I quickly realized with infrared, and it was that it was really cool that it worked, and it was pretty amazing to do like something that took me like a week, maybe in a second, with a certain accuracy. But then, the first thing I thought of when it was ready was, now what? What can we do? So like, and this is something that I found since then is very common to a lot of like, imaginary AI applications, or even like the ones you make work, that they're always open, a possibility down the road, like downstream in a machine learning parlance. And that's what my infrared did. So immediately, for example, large scale design exploration on the urban level became possible because you can now predict instead of simulate. So you can do hundreds of thousands of iterations, right? So that wasn't there before. That was partly on the work that I'm trying to do with quality diversity and sort of like new ways of generative design. And it also, yeah. So that was a performance based run. But then when I also started doing a PhD, right, and I just because like we're all locked down and you have to do like something additional, and I started sort of sketching this vision I had for the next couple of decades, what I want to work like. This is a system, how it should be, and it was split into these modules, right? And in fact, it was just one module out of 7 or 8 that I had, and so then I started and said, okay, what if I work on another module now? Let's do generator. And I started looking into like, gaming AI, like procedural content generation, all this stuff. It turned out it was really difficult. Like I could do generative design, I could do like random mutation and all this stuff, but it was really difficult to do anything guided, anything like constrained, right? And most of the designs that we did are actually constraint based. And even though I want to do diverse generation, like I want it to be real diverse, you need to have certain constraints. You need to ground it in something, right? So it turned out that from all the system that I had, all these modules, how do you evaluate? How do you learn preferences? How do you generate? How do you predict and visualize? It turned out that none of these were the most difficult. The most difficult was the beginning, which were a couple of very like they don't mean anything to anyone but me. I call them initiator and encoder. It's just the UI. So the UI and how do you input constraints as a designer to a tool that does to this sort of imaginary end-to-end tool, and how does that translate it into something an algorithm or a model can understand. And that was super difficult because essentially we do that in Grasshopper every time we make a parametric model, but it only works for that specific instance of that model. If you want to add an additional constraint, you probably need to change everything. So it's difficult because we have arbitrary constraints in design. And that's when I started looking into, okay, what can happen? How can we do that? And that's when DALI came out. So that was the second sort of exploration. It sort of blew my mind when I saw the blog post and a lot of community started developing it. And I sort of hitched on for the ride. And everyone was trying to generate everything like DALI does. I was thinking, can I generate something specific, right? It wasn't very interesting like we were in a Discord, all community, we're still there. Like it wasn't that interesting for the crowd at the beginning, what I was doing, because of course no one else was like in architectural design. But then when we ran, people started training models, and my first DALI model, it kind of worked. So people were actually started being a bit more interested, like, oh, this creates something. Also because it was a bit easier, like than making, I don't know, ImageNet or any other image. Everything came out blurry, but my designs would look like layouts in a way. So DALI was the first thing, and I keep calling it when I present it like design with language. So like that's the idea, and it bypasses this how do I integrate constraints into this generative method. So you can do it with language because we can describe what we want to happen, right? So that was DALI. And I was really excited because the more data I was creating, the better it became, the architecture matured. And at the end, it was really like even overfitting. Like, I don't know, I would generate 128 layouts. I don't know, 80 were good semantically, like very, and but then I realized another problem, and that what led me to the current thing that DALI creates images. And while images are very powerful and really, really amazing, very, inspiring, or all these things, they are kind of useless for the stuff I want to do in design. Like I want to do performance-based design, I have to have geometries, I have to have real things, right? And that led to architects. So architects was sort of like me thinking, okay, what if I take the image out completely, like because I don't need it. I can generate any image or any model I want if I have geometry, right? That came from my domain expertise in the one we all have in like Grasshopper, Rhino, anything. Like it's super simple. If you have like points, you make a rectangle, right? So that's what I thought. And then I thought, okay, let's see if we can do, I call this like language as design now. Instead of design with language, now language is design itself, right? So then that's what architects does. So that was the last part. That's where I am now. And architects literally works on the level of language. There's nothing that is anything visual in there. Everything visual is generated, right? Is processed. And it actually works. The amazing part about these three stepping stones is that what they work, like these four stepping stones, and they all sort of come together because now we have these sort of really powerful language models that can be used to embed constraints and create like very flexible programs. That's how I call these models. They are actually software programs. And we have like something like infrared to predict. We know it works, so it can work in other places. And I'm slowly building other stuff. So that's where you find me today. Like the next stuff, I think I've even presented a few of the next steps, what they would be probably something like my next step is probably going to be something like decision transformers, or like something that I can generate based on a performance. So that would be like performance driven generative design. I guess I don't know how to call it. Generative models, like where you will literally, again, instead of asking nicely for 3 bedrooms and 2 bathrooms, you can also ask nicely for 3 bedrooms, 2 bathrooms, but performing well in terms of some sort of metric. So that's the idea. That model will generate based on a reward, on a sort of performance input that you give it to. And of course, the more important thing is to do more than layouts. Layouts was really like, it's important. A lot of people do it. And, I really like residential design. That's why I did it. Like, I think you can actually design in houses, but there's so many other problems. And these techniques, they are, I think, ubiquitous. Like, I think that you can use it, like, as long as you can describe it, it will work, like, in a way. So yeah, that was the biggest response to what you asked, but that's sort of the introduction, the history.
I mean, there's so many things to unpack, and like, you, uh, I'm I just want to know that if, let's say, someone wants to use Architext for their own, let's say, office design, how is the process? Do they do transfer learning and then provide their own like data set with labels of text and images?
Yeah, so obviously this is like super new. Like literally, it's not like what I did was like a world first. It was a world first because no one in AI cared about making layouts. That's why it was. Uh, but it is kind of new. Like it is new in the sense that not many people had tried to create structure outputs from language models before. And now there are people that are much better than me in AI who maybe have taken, have seen these layouts and say, that's cool. Maybe I try it on my thing. So it's really early. That's what I'm trying to say. And everything is still up in the air. Like you can generate like the simplest thing that I can say, and that's what I've been describing architects is that you just describe what you want to have. That's all it is. That's all what the data is, right? And I think I haven't done it. I suppose that you can do it for anything. Like it can be an office, it can be a floor plan, maybe it can be like a neighborhood, right? Anything that you can describe in a way that one, the model can learn and generate, and two, you can use after like to create some geometry, right? Because again, there is no geometry, there is no images created here. So as long as you can find a representation that is flexible, easy to learn for the model, or like powerful enough to learn for the model, and then you can use it to create designs, then that's okay. That's all you need to do. There is no labels, by the way. Like of course there are labels, but they are not labels. It's not classification anymore. It's generative model. So they are just annotations in a way. So this is all you have to do. It's like you just annotate what you want to make, right? And the model learns. For transfer learning, fresh learning, all this stuff are unknown. This is the experiments I'm doing now. Like right now, for example, I'm doing a scaling experiment. Like I think I'm 160 models in out of 240 that I want to train. And all of these are from scratch, just because the scaling experiment is that. But I don't know which one is better. Also, there are many other techniques. Like every other week things come out, right? So there are techniques that you can use, for example, to add tasks to the model. So this is, so in language modeling, all these models, when like GPT-3, right, is a good model, but by itself is not like so good. Like, but if you prompt it nicely, right, if you do nice engineering, it works really good. Like it increases the performance like a lot. The same for these models. Like when you fine tune them, they are good, but you can also do other tricks. So there are tricks like how can you add a new task? So for example, if you have a model that creates layouts, can you take that model, add a few parameters and have it add windows on those layouts or furniture and all this stuff. So these are the stuff I'm looking about. Like there is a lot of things, but all are open in a way. Like I opened a personal for me, but I hope others join eventually. Research field, like for me, literally, because no one else is doing it on our domain again. Because obviously, a lot of other people, much better in sort of NLP and AI than me, are doing it in their own domain, but they don't know about design. There are a few papers, like I think what was that paper like? Actually, the title is really, really close. Let me open it now. I have it. It's really close, and you think like, oh, they did it before, but it's not exactly that. I do think I don't know if it was DeepMind. I have like a folder with AEC papers. There are like 4 of them out of the 1,000. So yeah, it's what is it? Oh, it's not Patchcat. No, it's not that. It's not here. It was something about CAD and language, like the language of CAD and language. I forget. Like, but it wasn't like they did something like that. They started like I think that's what they had. They had all these millions of CAD drawings, like literal engineering drawings, right? Not architectural, and they described them, but they didn't describe them in language. They just tried to learn like geometry, right? So it was kind of like close to that. So yeah, but that's the simple thing that I can say. You just take a language model like that knows to create language, and you fine tune it to create what you want. It's really parallel to what everyone else is doing on many other domains. Yeah, I don't know if that's clear.
Yeah,
And
like I just wanted to clarify that if I want to make like similar architects model, do I need like for, let's say for an office, do I need like set of office images and like text labels where, okay, these are like 4 office rooms, 2 kitchens, or like do I need
so
like additional labels inside that image that this is office, this is kitchen?
yeah, so yeah, if what you described is DALI. So for DALI, you will need something like that. Yeah, you need some images and some annotations. And something that you want to do. So architects, no, you just need annotation. You just need text. Yeah, you don't need images at all.
Oh, okay,
So
that
it
is
works. That's why the difference of design with language, right? You create with DALI, you give it some prompt and you create some image or some artifact, and that's it's wordplay, but it has a meaning. And language as design is architect. So it's really at the level of language that the design happens, and not at all at the level of images or or vision. Yeah.
I see. So like how does the model learn about like so I have seen multimodal models. So with architects, like if it has if with just language, no training, like okay, you did training. So that training determines like in training determines the output.
Yeah, you fine tune it. Yeah, of course there is training. Yeah. So you take the model either fresh or like pre-trained on a lot of data, and then you fine tune it on what you want to generate. Again, it's actually super simple. Like I'm very honest, and maybe this is bad marketing in a way, right? But it's really simple in a way. Like after you make it work, it's really simple what's going on. Yeah, it's just you just ask it nicely to create layouts and it does it. That's it. Like that's how language models are. They are, and it's much easier nowadays because there are so many frameworks and so many like open source models and all this. That's why NLP has this huge potential, I think, for every industry, including the AC, because like you can get this model pre-trained on like I don't know the largest data set out there. Just download it and play with it, fine tune it. So yeah, so that's how it works. That's how it works. And I do think that you can replicate that in whatever else thing you want. You can as long as you create data or find data. Yeah, that's the problem.
May I ask a question, please?
Yeah, no problem. Go ahead.
Thank you for introducing to architects, Theodore. It sounds pretty cool. And I also tried to experiment with it. It looks great. And I had a question with translation of the semantics to the building elements. How do you translate or convert from the semantics, the inputs that you say, the space program, for example, a living room or a bedroom, to building elements like walls, beams? I mean, in terms of data structure and storage, are then these walls and building elements assigned to rooms? Or the room and space
No.
label is not relevant? After you have the layout, then you don't care what the...
Yeah. So no. So it's very important, I think, to like reduce complexity in this stuff. Like AI is not for everything, right? I like literally everything I do, almost everything I work on right now is about AI, and yet you will hear me say that AI is for very specific things. You shouldn't use it everywhere, shouldn't put the label everywhere. So like when you go into these elements and construction stuff and how they relate the networks and where are these, is the wall and is the window on this wall, like all these are like at the beam level, right? Somewhere else that it doesn't really matter, and it's too complex for generation. It might be okay to do some machine learning there and graphs or whatever, but for this thing you want to stay on the simple. What do you want to create, right? So when you're creating a layout, you have very simple geometries. This is what you have, right? All the rest come afterwards because we can create walls. I can make windows if I want, right? Like if I want right now, for example, architects can be a performance-driven thing without AI. Because again, you don't need AI everywhere. I can have architects, right? They can generate a JSON, like a honeybee JSON. I can send it to pollination. You can put random windows and you can have like text to, daylight autonomy in houses and stuff very easily. But that complexity happens elsewhere. Like you don't want to put all that complexity in the initial model, at least. And at least my intuition, and maybe it's not, I don't know how it's going to go, is that all this will be a hierarchical way of doing things. Like, you have something that generates structure, then you have something either the same, same model with an adapter or something, or a new model that creates windows, then another model that creates furniture, then there is a process to relate all this, like according to these windows, daylight autonomy was predicted better here, so maybe the bed goes there. So like all this can happen hierarchically, but not in the generation. The generation has to be simple, I think, because you're already doing something really complex. You're going from language to design. So you just want to stick to like simple geometries, like that you can manipulate.
Yeah, very reasonable. True.
Yeah.
My next question is, so we have seen your experiments in multimodal space and GAN space. So I'm curious, like, what are your thoughts on like reinforcement learning and meta learning for AEC?
Reinforcement learning is, I don't know, like it's difficult. Like it has a lot of problems, right? Essentially, the only people actually having reinforcement learning work right now is DeepMind, right? No one else does it. Like everyone else can. I mean, there are a few labs that do it, but like I'm an observer. I'm not an expert, but most of the stuff sort of fail. Like outside of their random seed or their specific experiment, it doesn't work. It doesn't generalize. In architecture, the experiments I've seen, I haven't seen a tool. I don't know if there is a tool. Like maybe there is, and I missed it. The experiments I've seen, they just use RL as an optimizer. So it's not really RL. It's not. There's no world model. Learning how to behave and all this stuff, right? It's just something that has a reinforcement learning loop to optimize the layout. Okay, but you can do that with Galapagos as well. You don't need RL, in a way. So yeah, I think it has issues. Like I think it has a big potential in certain things, right? Like there is very interesting reinforcement learning with human preferences that I think fits with design. There is a very famous, very nice paper by OpenAI, I think, in like, again, language models. They do like summarization with reinforcement learning and human signals, so preferences. They say this is good or bad, right? So something like that has a place in design because we always do inference on our design. So this is nice, maybe not, right? But I think that is, yeah, I don't know. It would be something I would do towards the end. I really believe much more this decision transformer thing, which was this upside down RL. So instead of trying to learn all these model dynamics and states and whatever, like to have something that at the end gives you a good reward, instead of all that noise, and it's really noisy, you just say, what if I give you the reward I want? And you figure out a design that satisfies it, right? So that's decision transformer. That sort of RL, I'm behind. I think it has potential. The only reason I haven't done it is because I hadn't had the time to experiment, but it's on the roadmap. I hope very soon. So that one, I believe would be like the other RL, I think has potential again, because again, it does work. Like if you see DeepMind, right? It works. Of course, DeepMind is a collection of, very good researchers and probably the best engineers as well, because it matters. Like their papers are very engineered, right? The RL papers, like if you see AlphaStar or all the stuff, like, or the Dota 2, what was it? Yeah, all the stuff. Like it's super engineered models, like everything is in place, right? That type of RL, I think, has space in architecture, but not in the way like we're discussing now. Let's make a layout or let's generate urban designs, but mostly when you go to the occupant, which is eventually I want to reach there, maybe like in 10 years or 5 years, I don't know when, but eventually that system, that end-to-end system that generates stuff has to have like occupant preferences inside or the understanding of the occupant. And there you can do it. Like you can have like sort of behavioral design. Maybe you can create even like, and all these are very old. They're not really new. Maybe you have agents that have certain behaviors, right? And if you do have a very powerful generator, something like architects, if you do have something that can predict results very fast, something like infrared, then you can imagine adding behavioral stuff inside because it's tractable. You can actually do it fast and on a diverse design. So that type of RL, this sort of agent-based, multi-agent based stuff like that, yeah, maybe it has a space, hopefully. But the other style RL, like, let's just run an RL loop to optimize. I don't know if it has value. Like you're much better off doing like, normal stuff, different things.
Nice. And like any thoughts on meta learning, like learning to learn like models?
Yeah, I mean it's super hard. I don't know if it works. I don't know. Like I'm not an expert in this at all. Like the only work I've seen that seemed like it has promise was like, I think it's Jeff Kloon is the guy with Ken Stanley in OpenAI, and they had this. Was it? I don't know. It wasn't. I don't think they did Mumble. Mumble is a different one, but they had this like learning to learn. But it's really difficult, right? And all, everything was toy stuff, right? But their idea was something like Poet. Like something like Poet, I like, even for design. Like I think Poet. This is the enhanced Poet, like something Trailblazer. I forget the name. What it means now. Let me find just what the Poet exactly means. Like that one, pair-ended, paired open-ended Trailblazer. So in Poet, what they did, like it's an RL, right? But it's really cool because it's not just training an agent to do something. It also changes the environment all the time. So the environment becomes harder and harder and harder and harder, and the agent, learns a really diverse mix, open-ended mix of behaviors. And I think they had something related to that, like a meta-learning thing where the model had to continuously like learn new stuff as a meta-learning. Like I don't know. I think it's good, but it's a bit above me, I would say, and very quite far to the many steps I have until then. But something like Poet, like if we go back to RL, I think is really cool. Like I'm very like open-ended stuff is very central to what I want to do. So there needs to be diversity, and like this is symptom of working Grasshopper for so many years. Like it needs to be much more open. So something like that would be nice. So imagine, for example, again, you have something like Architext, and you can prompt it continuously with semantic annotations that increase in difficulty, right? What you're describing, you make it more and more and more complex. It generates stuff, and then you have another agent that goes in there and does something, and that's really cool. That's really cool. Because Poet was doing in this 2D walking environment, right? But imagine if you do it in this generative model, and then there is feedback between the two. Yeah, okay. So that stuff are really cool if someone has time for a PhD.
I see.
Hey, Theo. Sorry, man, I just had a quick question. Because he mentioned like something really interesting, and this is I do like the idea of like open-endedness RL, and it seems like there's been more exploration now in that. And David Ha, like the guy that wrote the Poet paper, he's been developing like other kind of interesting work around this idea. And I was just wondering because like I seen like even in like I guess the video game industry where you have now procedural generations and they're applying like reinforcement learning to like kind of test like how hard a level is, and they'll run like an agent. I guess they'll run an agent that creates like the level, and then they'll run an agent to test like how hard the level is, and it just keeps getting what's called, I guess, kind of like an actor critic, right? And the harder the game gets, maybe like the agent has to learn more, or they decrease the strength of the level. And I was wondering if you thought like, I guess maybe if this is kind of like would be like an interesting application to actually design layouts, or is it kind of like not there yet? Because it seems like the video game industry is exploring this. Maybe they have a little bit more leniency since they don't have to be kind of so like specific in dimensions or things of that nature that we consider in like architecture. I'm just curious about your thoughts.
Yeah. So for sure. I mean, I do think it has a role. Like, I do think that can be used in architecture, and I also don't necessarily think that we need to be very strict at all during these phases, like conceptual design. And for sure, like RL, I do think even like again the DeepMind paper, I think it was DeepMind, right? in like chip design with RL, right? Again, it shows that, you know, in this really complex combinatorial problems, like, you know, you can really do something cool with it. So I do think it has a role, but I like you said, I see it much more impactful in those sort of environments where there is a sort of co-adaptation between something. Like the RL is not just, you know, a loop that optimizes, but it's something that co-adapts an agent and a design. I do think, yeah, it has, and I agree that the gaming community is better. You know, funnily enough, I think they are better in PCG, in what we do in parametric design. That's why I went for a PhD in a gaming AI lab initially, because I thought, you know, PCG is really cool. They know how to do. I diverged a bit after, but that was the initial idea. And yeah, they do, like they have the ability to do like more tests. Like the big advantage of gaming, I think, is that it has its own like environment of experience. Like you can actually, you know, play test, like you said, stuff inside the game. So if you have a game, you can already play test. But how do you do that in architecture? Like, what is the environment? You know, like, so it doesn't really exist. Like maybe you could put something together in the Rhino. So I don't know. It's not very efficient to do it. So yeah, the things that I like in RL, I guess now I remember the new one, is this co-adaptation where the environment, maybe you co-create it, right? Your model is there is an environment, or these world models that's coming out. Like I really like that as well. And where, you know, you have a model that is its own, the environment of experience, and you can just ask it nicely. Again, it's not a language model, but you can ask it like, give me a state, give me and then it gives you like, okay, here's the design and the windows and I don't know, whatever you care about. And it's a state, like start and do something from here, you know, like something like that. So those two things are cool. And I think the second you can do again with a decision transformer. So like, yeah, I'm not sure, it's a hypothesis. Like maybe you can train a model only on, like imagine you would train a model only on actions. No, only on states. So imagine if it was chess, right? You just train a model on all the chess pawns, like on million different positions. That's it. With no, you know, with maybe a reward or something classification, but that's it. No, there's no playing, just positions. And then you have a world model of chess in a way. That's what I'm thinking. So I'm thinking maybe you can create a world model like that of design. So what are states in design? There are different designs, right? You can give them a reward. So something like that might be interesting. In a way, like I was saying before, in decision transformer, you know, you give it a reward, it gives you a design. What if you give it a reward and gives you a design state in a way, like, which is a bit more. So those are cool stuff. So those two things I think have space. Something like pod and something like world models, and yeah.
And I guess like to add on top of that, do you think, since like a lot of, I guess, the current, let's say like models that we can apply to architecture, they're mostly based on 2D, I guess, images and things like that. And that might be an issue, I guess, with the amount of size that it would take to compute like, you know, 3D stuff. But do you think, I guess, like speaking a little bit more speculative, that if we get to the point where we're able to compute like 3D stuff a little bit better, that it makes more sense to like go straight into that instead of using 2D stuff to like really use it in architecture or like in world making, or maybe not?
I mean, yeah, yes and no. Like, I think 3D is a distraction right now. It's definitely like once you like, you know, if I were what I'm doing with architects, if I was doing a 3D, it would be like a terrible mess. And there's no reason, right? You can always extrude the geometry. Like, we have the domain expertise to do. Like, a lot of people I think might work on 3D sometimes because, you know, maybe they don't know how to go from 2D to 3D. I don't know. But yeah, the 3D domain is like, the research is incredible. Like, things are coming out, right? There are like models that have really good representations of 3D space. There are 3D world models as well, right? Like you see like the drive gun and all this stuff. So it's possible. But I think once you go there, you change, I think there is like, you change the task. So like, I wouldn't do like, you know, not everything, most of the environment performance-based stuff, for example, on 3D, you don't really care. But some, yes. If you say like glare, for example, right? You don't have a grid anymore, you want glare. But still, if you go to 3D, I think you need to expand much more. You need to have like I don't know, maybe your model has a representation of the 3D space, and then if you connect again with occupants, very important, and the occupants tell you, yeah, this view is very nice, this room feels good, this room feels terrible, you can start sort of aligning, how occupants feel like in the building with this 3D representation, which is much richer than a 2D, right? So that might be good, because there you have textures, you have light, you have so I think once you go to 3D, I would only do it if my task changed, my design task changed, not just to have a 3D and look. Because architects, for example, is already 3D. It can be, as 3D as he wants. It's just geometry, right? You just if you go to train on 3D right now, I would do it. Yeah, I would expand on the tasks, if that makes sense. For example, an idea I have that I never did is like affect-driven design. So like you can maybe do experimental. There's no other way. Like sensors and everything, and you calculate occupant effect, which literally like as they move through space, either virtual or real, you get responses, right? And then if you have a world model of those type of spaces, you can sort of train it, okay, these are the pairs, right? This space has this affective reward, this space, this affective reward. And then again, it becomes a world model of affect, architectural model. So then you can say afterwards, okay, give me a state with this effect. And then it creates something, So that's interesting, right? But you don't need that for daylight or energy or, all connectivity or, all this kind of stuff. That are also important, yeah. Sorry.
Yeah, so I guess it would depend on what exactly you want to, in a way, optimize, right? Like I think that's kind of.
Yeah, what do you want to
explore?
Yeah, what do you want to explore?
Gotcha. Thank you.
Cool. Yeah, since we are on the gaming and PCG discussion, so I saw you attended summer school for gaming AI. So wanted to know your thoughts, like what are some highlights from that school and some trends in gaming AI?
Yeah, I mean, the trends in I'm not of that domain, so like all these trends are probably gonna be not the best, but like from presentations I've seen so far, I think it's the same issue, just a bit more mature than we have in design, right? They actually know that they don't have to use AI for everything, right? And even like the actual game's AI is not like AI, right? There's a lot of rule-based stuff, or like this old-fashioned old-fashioned AI. So, but most of it from what I see is about content right now, because that's what makes money. And it's very tempting to do that in design as well. And people in a way are doing it in artistic design right now. There millions and millions of NFTs and stuff like that. But it's very tempting to also just do it in design. Like, okay, it's very difficult to design. Like, it's actually difficult to design sometimes, right? Or it's difficult to to imagine and stuff. So if you have this sort of content generators, would be good. So this is what I see a lot. And the other thing that you said is I've seen a bit playtesting, like because that's also a lot of cost. Like the gaming industry is a lot, it's very costly. Like all these games cost a lot of money. So that's why I think they focus there. And I wonder like if the same will happen in the AEC, because our projects cost a lot of money and the margins are very low and stuff like that. So yeah, the other thing might be playtesting. I've seen some trends about trying to understand how users behave and what how they like the game from that. So there is a lot of behavioral stuff in AI, and there is some AI work there. Again, or sort of like affect, like from footage, try to understand like how the players feel and what do we need to improve. So that again would be really cool in architecture. This goes back to what I was saying, like if you have something that had affect, how people feel like, like that's the dream, right? Because if you could reach there, you don't need daylight autonomy, you don't need like, you don't need all this man. You just have directly how the occupant feels in a way. And so that's what I see in gaming. Gaming in relation to the AC is the relationship is really close. Like we can just borrow all the PCG stuff, right? And they do really cool stuff. Even their software is better. Like even Houdini, I think is better. But anyways, like they're a bit more ahead. It's just that they, like there's not a lot of connection. I mean, there is some connection. Like we do a lot of VR, and that's gaming. I don't know, and AR, but there is not a lot of connection with PCG, which is maybe that'll be better than AI.
I see. And so one of the challenges I see in like AEC development is like open source models and the data sharing and formatting. So what do you think would be an important data format in order for future ACI developments? And I mean by like from Revit, Rhino, like object data, metadata, and what do you think would be important?
The format,
Yeah, like
language. That's the format you need. Just text. Yeah. So literal language. Yeah. Like for me, like again, when you go to like actual import, export, and all these files, like Revit file and Rhino, it's already past the point where I want to do AI personally, right? I want to do AI at the concept design phase. Like that's what I want to do, and I want to do it not just to do concept design, with AI just because it's cool, but because I want to change how we do concept design. Like everything, like that system I was explaining with the modular stuff, it's supposed to run at scale. That's my goal. So like every time you want to design a house, you don't do a parametric with 100, you have 100,000, 200,000 pre-calculated, and you can search in there. So that's, I think, the scale. Like it needs to be at scale. But yeah, everything else, like all the detailed stuff, okay, like which format and how, which softwares we use, like all this, I think, is after AI, or at least at that level, you should use. I think it's much better to use like ML stuff, right? In the sense, like you have a lot of data, you can do classification, you can do like clustering, similarities, right? Retrieval, all the stuff you can do after that complexity. But before that complexity, I think language is enough. That's it. Like text is enough. And so like a lot of the things that we need to do, like I've talked a lot about how we need to create like data generation processes and data pre-processing and storage and retrieval and all this stuff, right? We need to do it. But I would definitely consider when to do that to add the semantic aspect, like the language there. Because you can see it like if you like just follow the papers that are coming out, you can see how it's not just multimodal papers everywhere, right? Like multimodal for video, multimodal for text, multimodal for object detection. Is that everywhere that you just add language, at every task, they just added a language. Like, oh, look, we just put some text there and an encoder next to what we literally to the same model we had before. And it's now state of the art. It makes everything like, it supercharges everything, because it's so rich. So I would suggest to all designers to just, keep or create in parallel annotations, right? Create language. Like if you're doing a grasshopper parametric file, design it in a way that exports language somehow, something about your designs. It has to be at that point. If you do it after, like it's not going to work. And so, yeah, that's for me the format. AI will work at the concept level, right? At least for the next 5-10 years. Of course, like you want images. If you can have images, really cool. Like I'm not abandoning DALL-E, for example, at all. I will go again to do a DALL-E now, for example, because I have like 3 million layouts instead. Like I keep generating layouts from the models. That's the other cool thing. If you have a nice model, you can just prompt it and generate, random layouts. And so images are okay. Like all the modalities are cool. Like you can add stuff, but text is, I think, the most important. And we are lucky because a lot of, even like if you are at the complexity of Revit right now, or Beam, Beam files, you are lucky because everything is text there in a way, right? And maybe you won't be using like language models like the ones I'm using, like autoregressive stuff. Maybe you do like some sort of graph model, or maybe you do like some sequence model, but still text, you can use that text for that. Yeah. So in my opinion, the most important will be language. Yeah. And the other modalities will follow. Yeah.
So like just to clarify on that, let's say I have a Office, Revit, or like any BIM model. By text you mean, okay, this office has this many rooms, this many area with this many square feet, like that kind of simple text, or
Yeah,
like more
everything.
granular?
Yeah, everything.
Okay.
Oh, as granular as we want. Like, of course, I don't know what will work. I haven't, like, again, this is like brand new research field for me. And in fact, it's probably for everyone because simply because I haven't found anyone else to
Yeah.
just say, okay, what happened? How did your experiment go? I haven't found, right? So it's brand new. And yeah, maybe it can work. Like for me, I would just download the whole Revit metadata, whatever is there. And then I will try and test, okay, what can I use from here? It's really, that's the cool thing, that it's no longer like, it sounds bad, but it's really cool. It's no longer like pure AI research, right? It's not. Why? Because I've said this in other presentations. All these models are going to become simpler and simpler. That's the cool thing. Large scale, simple architecture. What is the architecture? You have a bunch of text and you go one letter at a time and you predict the next. That's it, right? And you have off-the-shelf pre-trained models, perfect libraries with two lines of code. You don't need any of that. So what remains? The domain knowledge, right? So what can I do with that? The thing that will remain in these AI applications is designers sitting in their screen, right? Looking at the screen and looking at this data and trying to think, imagine new ways of using it, right? And I haven't imagined all of them. I have imagined a couple of them, and I cannot imagine all of them. But that's the cool thing about it. Like all these AI applications will not be about, oh, look at this new architecture that I made, right? And they shouldn't be. Of course, if someone does it, very cool, I will upload and it is amazing. But I don't think I would ever sort of spend my time there because it's not the best use of my time. There are other AI researchers that can do it much better and actually want to do it. So the best use of our time is this. And I do think like, yeah, that's a really cool part of all this, that it's all about your domain. So yeah, I would download the whole metadata, look at it, and then ask for different tasks, right? So the civil engineer will say, this is important. Maybe this, yeah, this thing here, this relationship, excuse me, is very good, and all this stuff. Like an architect might say, I don't care about this stuff, just keep this. But, so the same data, that's why it's so rich language, you can shape it and mold it in for different tasks, right? And that's how this future is going to be, I think. If it take off, which I hope, of this like language as design, it will be like a lot of like, different tasks, narrow, like parallel tasks, where, the only difference will be like, okay, the same data sliced in a different way, according to my expertise, fed in the model, right, and creating something else. So that's how I see it. And I don't know how it works, I'm honest. Maybe it doesn't work, right? Maybe all of it. Maybe you pass the whole metadata like line by line and the model learns. I don't know. I doubt it. It should be a bit smarter. And there are other cool things. For example, there are knowledge graphs we can use, stuff that are decades old, right? Graphs like, again, the BIM is all relational data, right? Cool. So you can use it because it's not all about generating. You can use it for other stuff, yeah. So for example, maybe you want to repair your BIM models, right? You could do it if you had models that understand relationships, yeah. So yeah, I don't know. I keep drifting off the question, but that was...
Hey, I had another just quick question. So recently, I think a paper came out where they were able to control a robotic arm using language.
Clipboard, yeah.
Yeah, and that was kind of interesting. I mean, that was kind of like one of the first uses where I saw, like maybe Clip can now be translated into other domains and actually be useful just besides like generating stuff. And that might be kind of like the way where like within the next year or two, we're just going to see people just kind of writing papers and developing all types of applications just kind of based on this same approach. I was just curious like what your thoughts are about that.
Yeah. I think Clipboard is amazing. Like I think I mentioned it in a LinkedIn post of someone like it's amazing because it's the semantic revolution I keep shouting about. You just ask it nicely and it happens. So like Clip is obviously like amazing, is really powerful and everything. But even if you take Clip away, like the main point of that paper is that, here's a task that we've been trying to solve for a while, right? And it's difficult. And to solve it, we gave all these images and handcrafted stuff and, the degrees of freedom. And here the same thing, and I just added the semantic annotation of what I wanted to do. And it suddenly learns better, and that's it.
Yeah.
So that's what I mean. Yeah, definitely Clipboard can be used. I think it would be if I can clone myself, right, I could do it. Like if I was younger, maybe I would do robotic fabrication with semantic guidance, right? Because you can see it there. It's right there. It's ready in a way. Or like manufacturing, I'm guessing. So but all this is what I was saying. All this, you add the language modality and it suddenly becomes richer because all the other stuff, they're not really new. Like the only new thing they are doing is, okay, we have another modality. How do we bring it together? Maybe do we do like anything contrastive? Like, is there like a cross attention? Like, it is not, all the rest are the same. It's just like, I added language and suddenly it took off,
Yeah.
And yeah, I really think Clipboard is amazing. Like, I hope to do it in the next design intelligence reading group if I can. It's not my domain, so I will fumble a bit. But I think it's amazing. It's just an example of how this can be used in AEC, because AEC is much more than layouts and designs, right? There's also construction, fabrication, all this stuff.
Yeah, so they were using imitation learning, which is kind of interesting because then now you can apply some sort of metric, whether you like this or not, right? And then combine it with Clip directly. And then you can, I think that was, me and May were talking about this the other day, where like you can actually kind of apply maybe that to generate like a 3D model in Rhino somehow, where you can have somebody, I guess, record the actions and then provide the semantic text to it and then generate something out of it based on language.
You could, but it would be a really weird roundabout way to generate designs, I guess, but it would be cool to see, like,
Yeah.
Ask a robot to make it, you can generate it directly, I guess, without the robot. But yeah, it would be cool, and I think it has potential. And I want to see it in actual tasks. If you can train it to do like tasks we need in a way, like, can you build this wall? Can you do this stuff? Like, and yeah, the imitation learning, I would take it out personally. I'm saying this as the non-expert I am. I would do decision transformer again. But yeah, because it's simpler. It's just simpler. Like you have all the sequences. I would imagine what I could do. Yeah, maybe all the sequences, maybe a text, and then you bring them together. I don't know. It's really amazing. No, it's really like, and the cool thing is that you can understand it in the sense that you don't need to be an AI researcher to understand what they're doing. It's just like, okay, they have this system with robotics, and they're also using literally telling it what it has to do, and it learns better. Like it's really amazing. Like.
So, like, I wanted to know your thoughts on two ideas. I think Daniel and I discussed about this. So, one is like, is it possible to create like BIM AI assistant tool? So, this is like inspired from like AlphaGo. Like, how if I move a wall, can it take? Okay, this is the impact on the sustainability performance, like carbon footprint.
Yeah, I mean, you can. It depends what you want the assistant to do. Like the things that I think you mentioned, you don't really need the AI again. I'm trying to resist the AI everywhere, right? There are two things I don't like. I don't like AI everywhere, and I don't like AI vague in a way. Like, so you can say I have, AI here, and by AI I mean this. Like I'm very particular with this. So like, I think those stuff, you can do it as an assistant in a way like Clippy, you move the column, some calculation behind, this is the impact, right? But yeah, it depends what you want your assistant to be. I do think of a design assistant, partly this model, this end-to-end application that I am imagining in the future. It's also partly design assistant, but not like, there is a voice telling you, oh, maybe you should try to do this, right? Somewhere we need to design new interfaces that don't exist. I don't know, right? I imagine that as a design assistant in two ways. Like first, as I said, you work in very large scale stuff, and it has a way to visualize, communicate what happens there. So like, for example, even in BIM, if you move something, right, instead of just saying the direct impact, you could say like, okay, here's where you position your model now by changing this thing in the vector space of all these other models that we've ever made, right? And this is how close it is, right? And then maybe you stop playing with columns and you go there. You say, oh, okay. And what's the closest model toward that direction? What is that direction is cost, right? And what's, maybe you start working like that in literally like, it sounds like weird, but I've been thinking that it might be like almost like Jarvis and Iron Man, like I know like it's all fancy, like silly stuff that you don't need. But this idea of like, looking at networks, right? But yeah, so it depends what you want. To start with, like probably like I would say like this designer preference is good. So like have the system learn from you, right? So that it can assist you in a way to initiate stuff or guide you towards what you have shown that you need, right? Of course, with a way to bypass that. And the other is this design space thing. The other assistants, like I think we can already have, but I think that the reason we don't do it is because that's too noisy, perhaps, right? If every time you do something, right? So maybe on the direct feedback, the intelligent aspect of that could be when to tell you something, right? You can do it rule-based. You can say, okay, only highlight something if I change this much, right? But it could also be intelligent in a way. So that maybe that's something like where, the assistant only highlights something that only when it matters, and not all the time. I don't know if that's something, yeah.
I see. Yeah, I think that's a really interesting point. It's like you could have an assistant who can say something, but also like maybe instead of changing, it can trigger warning. Okay, the next step might cause this implication. So just give it that thought. So, and the second thing I wanted to know your thoughts on, like using like NLP for coding. Like so, the idea I had was how we can use it for like to connect it with the Rhino geometry or Revit geometry and say, okay, make a cube of this dimension and like morph it like those commands.
Yeah, I think I really like Codex. I really like it because it's really cool. It's also a bit ironic because the last like how many years, maybe 5 years, I don't know, 10, like everyone has been saying how you need to be a coder, right? You can't be an architect if you're not a coder. It turns out, you don't need to be a coder because Codex will come out and you will just ask it nicely again. Hi, I'd like this and do this, and then it gives you the code. Of course, you still need to be a coder. You need to understand all these systems, right? But I hope that these models, if they don't end up like, killing us all or whatever, like I hope they sort of like bypass all the need to be like a developer or whatever, a full stack developer, architect, like I think that's a bit too much noise, like in front of what you are actually supposed to do. Like I think the reason why it's so I don't know, like I don't want to say it's bad. It's very, because a lot of the things that I do I cannot deploy, so I really need someone that can do that, right? I'm not like a front end or a back end engineer, right? No, I'm not full stack at all, but I don't understand why designers have to be that, right? You can find some back end engineer that, is actually. So I think the reason why it's become popular is because of the way we design and we do projects, it sort of goes, okay, I want to do this faster and chop it down like that. And so like, maybe if I'm a full stack, I can help the projects go like that. But we don't need help there, I think. We need help in actual design, in sort of like inspiration, intuition, perform all this stuff. And that's not about backend and full stack. I again traversed away from the question, but I'm going back to the question, I hope. So I'm really excited about the code. I think there are a few things that you could do. I saw some examples of people making like Revit code or Rhino code, right? Of course, it's not going to be perfect, mostly because, I doubt we have a lot of code like that out there. Like, maybe is there like, I don't know, maybe a couple of GitHub, like, I don't know where they can find Rhino code or Revit code. I guess Dynamo has more. So yeah, and the other thing that you could do is create programs, that help you around design. So it doesn't need to be Revit or Rhino or anything code. It can be like, think of something you would like to do, right? So maybe you can tell something like Codex, I have this design and I would like to create this algorithm that does this on top of this, on this data representation. And then it tries you the program, that would be really cool. In a way, like no longer needing something like Dynamo Grasshopper, and I love Grasshopper. This is where I did most of my work. But no longer needing it would be amazing if you could just do it on the level of code or algorithm, right? Create something that a small container I need right now for this project, right? And flexibly, that would be nice. The other thing I wonder if it works, I don't know how it does with XML, because like one project that I never took off, probably because I had no data, was this idea of generating Grasshopper files. And the cool thing is Grasshopper files that are just XML underneath, like you right click and save, I think, or something like that. So like maybe, I don't know how it does with XML. I don't know at all, but maybe you could do something there. Yeah, that last one is probably not a good idea. Although that representation is interesting. Like if someone has like tens of thousands of Grasshopper files, they can, let me know. And I think you can do some cool stuff with that, with the representation behind it. Because if I remember correctly, when I looked, they have relationships. Like you can literally see in the XML, you can see this component, the name, the connection to it, and all this stuff. So you could do something, even with language models, yeah. But yeah, Codex super nice, mostly because I think it changes this future of design. I think not for just design. I think it changed, like all these AI tools they are incredible, right? They are not AGI, but they are incredible. And I think they change a lot of frontiers for many industries. I think something like Codex, because it works so well, it has the potential to also change this sort of future of design that we're saying, like code is everything, Maybe code is just something a program does, and design is everything. Yeah.
I see. That's interesting. Like, so like the way to work around is like once you find those Grasshopper or programming files, you do like fine tune the Codex like model on top of it. But the thing is like Codex is exclusive. So like Hugging Face has not come up with an alternative for it yet. So I'm waiting for that.
There is a small one. There is a J on code, but it's not as good. Yeah, it's not as good. Yeah, I mean, that's another issue. Yeah, the exclusivity. But I don't think it will work in smaller scale. Like, I think it needs to be at that scale. It's kind of difficult problem in a way.
Yeah.
There's also like this current movement I've seen more like no code movement, like in software engineering, or like where people are developing like startups. Since now like a lot of these tools can sort of be packaged, and like companies just work on development like or like these new startups are now developing like no code platforms where like somebody can just hop in, do what you got to do fast, and develop like some sort of company around it. And then maybe once you scale up, then you can bring kind of like the more expert programmers to your taste.
Yeah, I like that. I mean, again, you need code, you need to understand it, right? You need to do anything today, right?
Yeah.
But I just feel that it shouldn't be a prerequisite to design. And I feel a lot of discussions around it, like I get that impression that, oh, it's a prerequisite if you want to be a designer. I don't know why, maybe, maybe it's not, I don't know. Yeah.
I see. And like one thing I noticed, like you are active in like a lot of communities and platform. Like I see you in Hugging Face and a lot of like ML communities. So can you share like how do you keep up with the trend? What are the Twitter profile you follow and communities you recommend?
Yeah, sure. I mean, for papers, you just follow the AKs. That's easy. So you can find them like, I don't know, AK43901. I forget his their handle. So there are a couple of Twitter. Like, of course, in Twitter, you just build it slowly. So after a while, I never used Twitter up to this year. So all my previous Twitter people were some from our industry, some like basketball and stuff. After a year, the biggest part of the people I follow, they are like researchers. They've done cool papers. Then I click the follow, that's all you need to do. But there are some people like AKI, for example, filters the thousands of papers that come out, right? So that's a good person good people to follow. And again, when you see some work that you like, just find that researcher and follow them. That it's really simple. Like Twitter is really simple like that. For communities, I mean, I think L43 is the best, and they call it in English, I guess, is L43, Okay. Eleftheria is like the Greek list thing because it actually means freedom, like freedom for AI, like it's the Greek word for freedom, and they are really cool. Also TPU podcast and the DALI communities. There are a few really cool. Like you need Discord. That's what I know. You definitely need Discord. That's something I see. Like I don't know. I don't think it's very popular in our industry, and it's a shame because Discord is amazing. Apart from the fact that it's free, completely free, open source, and it doesn't log anything from what you say, which is like the opposite of every other social, platform, right? It's also really cool. Like it works, it's efficient, like all the stuff, and all the cool communities are there. So I really highly recommend Discord and the ones I mentioned. They're really cool. Like I'm there. I'm a regular by now just because I'm there. It takes time, right? These communities, I've tried to make one of my own, and I'm not even regular there the last few months, but it takes time because out of the 10,000 people, just like 50 are regulars, right? So you have to really want it. So when you find a community, you will click and see. So I have a few Discords, out of the 15 Discords, like a couple I found. So it's the same, I think, story for everyone. Just like find what you care and go into those communities and then be active. Like the first stuff I was asking, of course, I didn't know. Like I was trying, but I still tried, Not everything is very beginner friendly, Discourse and stuff, but I tried and mostly I read, I listened, right? And you learn so much in there, like so much. I'm so much better now than I was a year before when I joined those Discords. I'm still not nowhere near like AI researcher, but I'm much better, like at a level where I can discuss, and have a discourse about this. So yeah, L43, TPU podcast, this kind of stuff. What else is there? Like even those two, if you are, is okay. The DALI is really good. The DALI PyTorch thing. Yeah, if you like generation, there's like novel AI, like all this stuff. Like, what else do I have? I can open my Discord. But yeah, get Discord and get like, get in Discord anyway. Yeah, there is an AlphaFold community, which is really amazing. Like, I'm not a biologist. I'm in the AlphaFold Discord, right? I'm not a biologist, but still I've learned so much in there because I can just ignore the stuff that are way over my head and just, some ideas are like, so yeah, just find the communities that you want. So definitely I recommend those communities.
Yeah, I was gonna say like once I got on Twitter and used it for like kind of just to see what interesting people are working on, and then you start following one, and then they start posting some interesting things, and then you start seeing like kind of like cutting edge things in the field, much more faster than they would get reported like to other mediums. I found that was like huge, or at least like I noticed like over like the like the last year or so, like people now kind of can go directly to Twitter and follow somebody like Act, and you're gonna get kind of like some top-notch paper that like it's like one of the most, it has some really impactful things, versus going through like archive or like, I mean, papers with code is also kind of interesting, where they're kind of trying to build this whole platform, and then now they they have I guess like how you can test code like from the papers and stuff like that, which I think is very interesting. Yeah. And then the other guy, Lucid Reigns, like that guy is incredible.
Lucid is amazing. Yeah. That's the people you find when you start following. Like Lucid is amazing. Yeah, he's like the biggest asset in open source, I guess, the AI. But yeah, but these are the people that you need to find. Yeah, because they provide a lot of knowledge, like for free, right? And yeah, for sure. Like, unfortunately, like it's Twitter. Like, unfortunately, I mean, I like LinkedIn. I'm quite active. I was quite active there. I'm a bit less now. But LinkedIn is not for this stuff. It's a bit business oriented. So unfortunately, my Twitter is like not as active. But slowly a bit. But that's where I think. Yeah, I agree. That's where you find like research. At least for AI, I think that's what it is. Like a lot of like nice discussions, a lot of papers. I do archive or archive. I don't know how you say. Yeah, I do that mostly. I guess, and through the AKs that I mentioned, like the couple people that I don't know if people probably don't know them, right? So let me do Let me find the exact handle.
Papers with
So,
Code does do like a pretty good job also of like narrowing down topics where you can like hop in on a topic and find
yeah.
like
So imagine that, but for state of the art, for literally every day. That's what AK is. So you need to follow, like,
yeah.
for people that might be listening, like the handle is AK92501. And what he does is he literally filters everything that comes out, and then posts like good papers. So that's how we follow papers, like the community, most people. And also Aaron is the other AK. So yeah, they do the same. And then yeah, I mean, after a while, like I have a folder, right? This is like a meme actually. It's a very nice meme. I have a folder, I don't know. I have now 29. The first layer has 29 folders, right? My literature, right? Maybe in total I can search. I think I have like more than 1,000 papers. I don't think I read more than 30, right? That's how it is. Like it's more papers you put to read, but slowly, even if you don't read them, like only abstracts, you create a knowledge base,
Yeah.
And is a knowledge base you can retrieve stuff. So like, oh, this new idea, I saw it before. You go there. So and of course, slowly I am reading them. But slowly, the most important thing is that you slowly hone in on what you care, right? Like right now, I'm still downloading interesting papers on all these categories, the 29 folders and subfolders, but I don't really care about all of them. I've honed in into what I really care. So that helps. That helps. And but to do that, you need to try. Like you need the effort. Like that's what I was saying to the people when I was presenting this stuff. My whole point about you have so much to offer to AI to when talking to architects and designers was to try to push people to like just try. Like it's okay. Like if you don't understand anything, right? The first thing you read is fine. I didn't
Yeah.
understand anything when I started. Literally, when I started doing machine learning, I didn't know how to code at all. Like not like the only thing I had seen was Hello World, and I started looking at TensorFlow 0.7. Like it was madness, but it gets better. And again, you don't need to be like super developer, full stack, whatever. Like the cool thing is that most people that I talk to, right, or maybe hear this stuff, they are already much better than I was there. So you're already like 5 steps ahead than I was, right? So the other wall to climb is like to break is like this. Yeah, but what do I know about this? Like, no, so much. Your domain. Like, find the domain that you care about, and So, like, none of the people inside this Discord, like, very few know anything about like what is CFD. I don't know. Daylight. All the stuff that you might know or I might know. So, like, yeah. So through this effort, it does need effort. It's a daily thing, right? You find the stuff you care about and then you do. Of course, it's not for everyone, like, because I've been quite lucky to like have time to research on the stuff. I think a bit with the remote life. Okay, we don't have a life anymore, but there was more time to research. If you are like, have a lot, office work and stuff, it gets harder. But that's why it's more important to do it then, I think, because you need to find a way, people need to find a way to bring it to their work, right? And to bring it, you need to show something. Like when I started, I had to show something as well. I was working like, so like, that's why it's important, like a small win, like something simple, like, look, I took this model and I created it, and now we can have like, bounding boxes in these images. And it's really cool because maybe it helps, like small wins. And then you get more time, or yeah. But yeah, that's how you start. Again, I drifted very far away. Twitter, Discord, all these people follow and read papers. This sounds very weird, like the last thing. When I present to people, right, and even when I talk like a bit more professional, let's say, everyone like hears like research or whatever, like, oh, okay, like it's done. Like the minute you say research is done, it's like the curtain is down. This guy is a researcher, like why do I talk like, well, here we want to do actual stuff like practice, right? And it's really important to like completely delete all this. Like there is nothing like, what we are seeing now is like everything like being created as we like right now we are watching it being created. So this research is practice and practice is research. Like it's not like it's not different, right? So reading papers might be the best thing to do for your work right now, like literally reading these papers, like I'm trying to convince people. It's very hard. Like even if I start my whole presentation with like I think 4 slides about this, like the dichotomy about research and practice and please and don't take it like that, I don't think it's very hard to break through. But promise me it's like that. I promise you it's like that. Like the papers like might be the best thing to read about your actual work. It's really weird.
I see. So I am aware that it's a bit late at night at your place. So to be conscious of the time, I'll ask like few questions to
Sure.
before we end the interview. So since we are on the topic of research and practice, I'm very curious to know your thoughts. Like, what are the gaps you find in research and practice in AEC? And like for me, like we saw style GAN model on like or GAN models on a flow plan, but like in practice, a tool like we haven't seen at that level and like scalability or robustness. So like how do we change this?
Yeah. So, I mean, again, there are a few issues here that are not new to our industry. They are everywhere. The first issue, and I don't like to repeat it, but the first issue is this thing that we overpromise. We sort of use the terms without them being there. That's very bad. I want to repeat that it's very bad because it really ruins everything for everyone else, right? So like if I say architects is AI, wow, look, it creates this crazy stuff all with AI. If there's no AI behind it, I literally jeopardize everyone else that is researching AI because people say, "Oh, I opened it, it was nothing." All this stuff is a lie. So the first thing that we need to make sure, and that's why we need to start small. Instead of saying, oh, all this tool that I'm making, all my startup is AI. Okay, maybe not everything I do is AI, but maybe this very small problem in the scope of problems, you're using machine learning to solve it. So we start small, right? Smaller. And the other thing that we need to do is we need to intersect with other fields. That's hard because other fields, they have better rewards than us. But and then start like just being up to date with the research and try to find these connections. Like for example, Clipboard, right? Why should I be like? I want more people to be like everywhere, saying, wow, Clipboard, this is amazing. We should do robotic fabrication with it. I think people should already be thinking about this, even from the first day they see it. But we are, and this is something a friend said from this Discord community. It's really amazing. I think insight. We are at the point right now with these models that we are in this sort of uncanny valley where these models are so good, they are hard to believe. And in fact, no one believes them, right? So because of that, I feel even research and practice is hurt. Obviously, practice because no one is investing in it right now. This is very far away, 10 years away, and all this nonsense. And research because people won't take the decision to go research it because like this is it has to be a lie. It cannot be like how can you like prompt this and suddenly give you all these good results. Cannot be like that creates all this stuff. How can I give GPT-3 an English sentence and then translate this, and it gives me friends, like how can it be? It has to be like. So we are at this point where these models are, they are uncanny valley in the sense they are really too good to be true and people don't really know too much about it because they're very new. So there is hesitancy in research. Thankfully, there's now like a lot of people, PhD positions, research. So now it's important to guide that research. Like, what do you want it to do? And for practice, the problems are different. Like, I think that the important thing for practice is, again, to not overpromise. And when you go to start with the low-hanging fruits, and there are a lot of low-hanging fruits, right? Architects is not a low-hanging fruit, right? I made architects work in like maybe a month after 4 years of stuff though. Like, of course, it took like a month to sort of, oh, look, it works. And of course, because other people have done like so much work on these models for a decade. And because I've done like but there are much easier things before that, right? And so I think in practice, we need to start like that. We need to go like for people that are taking these decisions, right? They need to sit down and say, okay, what are our problems, right? Ask the designers, the engineers, okay, what's your problem? What would you like to do, right? Doesn't need to be always AI, I repeat, right? But the places where, some machine learning or deep learning model can help, then select those low-hanging fruits, right? And do it. And the only thing that needs awareness now is that these low-hanging fruits, they have really changed height right now, right? That's the only thing that people, again, because of the uncanny valley we are in, they can't see that the low-hanging fruit is also actually generating something with language. You know, it might be low-hanging fruit, but still start from lower. You know, like prediction, for example, is something that you could do, right? Something predictive. Why not? Like so many people have done. So that's what I would do. And then the final part about practice, what I see, I think this is very personal comment that I will make, is that like I'm not sure, like the young designers that I see and like engineers, designers, they are fully ready, right? They are like all of you, like they are doing in their free time, clip art generate, they're ready, they're playing with these things, they don't know what to do maybe, or they do, doesn't matter, they play around with these things. But there is a big part of the industry that is not ready, and maybe it doesn't want to be ready, and that's okay, it doesn't have to be. But but as long as like a lot of people are in the place, in the positions that technology innovation is guided from, right? If that position, that person is not committed to this, right? It's going to be hard in a way. So that transition is happening, but it's happening slower. And I think the cool thing about this transition is that it doesn't matter if like companies do it, for example. It doesn't matter, because if they don't do it, other smaller companies, or like, maybe the two of you or whatever, will disrupt them, So that's the cool thing, that this transition will happen anyways. I'm just sitting here watching it, like in a way I can see it happening. It would just be much better, if the biggest actors in the field would be more proactive in a way. But I can understand, again, there's a lot to win and a lot to lose, right? That's why I'm saying. So to convince, to push them there, show them low-hanging fruits in a way. Don't overpromise, right? Don't fail, because if the project fails, like done, is the first impression, right? Oh, okay, that was so silly. Let's not do it again. So yeah, I don't know. That's my practical advice for practice. For research, I think research is going well. I think a lot of programs, like a lot of people funding. So I think that's okay.
Yeah, like go ahead.
Oh, no, sorry. I just wanted to say, like, he kind of makes a good point. Like, if you think about it, like, let's say bigger scale companies, they might be a little bit more resistant to testing out some of these new products or techs. And the reason is like they already have like a system in place, like that's established, and it works for them. And older people or management or executives, they're like, well, if this doesn't increase productivity or revenue, then it's like what we're doing should be fine. So that's where I think like smaller like scale companies or like startups, they might have like some leeway in that they can probably adopt this, and since they're starting from zero, they can probably take more risks. So yeah.
I should say that I don't think the executives have any problem with AI at all. You just need to show them that there is value. That's what I was trying to say. Right? So that's why you start like not over promising, like make a project, have a win, like here, we did this, we saved, this much time or whatever. I would start by saving. It's not my vision of AI in design to do things more efficient, but you should start like that. So if you show them here, we did things more efficient, can I do my next project on to do things new in a new way? Maybe they say yes, right? So yeah, I don't think they're against, but like you said, that you need to show the value. And even more importantly, don't show a failure in a way, like don't promise like the sky in a way, right? And no work. So yeah, I do think that level should be okay. I mean, it's mostly between us to commit to it in a way.
Yeah, like to your point, I feel like the skill which we might need is like the young AC tech professionals who are playing in this domain, about like quick prototyping skills and domain customization of like for those low hanging fruits that they can try out different fruits, and out of 10 fruits, maybe the industry is interested in one fruit and that can blow up. So
another good point, I just because you say that, a lot of I feel that many people feel excluded a bit with the AI, right? Because like I don't know anything about it. Maybe I'm too far ahead in my career to actually have time to do it. Like maybe I'm managing stuff, right? Or like mid-level, doesn't matter. So like maybe people feel excluded. And my whole point about domain matters and my whole point about these AI applications are not going to be about the AI necessarily, but about, how you can play with your data, feed in all this stuff. That means that the people with experience actually are the people that can lead this, right? So that's what I'm trying to communicate to the industry in the way that the people that might feel excluded because, I'm not young enough to do a PhD and do all this stuff, I don't know, actually have the best knowledge. Because just coding a deep learning model, it's not going to do anything. I can take it off the shelf. It's not the important thing. But actually, like knowing this domain, like this specific thing of design task really well, then you can guide, you can create. Yeah. So that's my other point. That don't feel excluded. You're probably the most important person.
I see.
Yeah,
Yeah.
I wanted to add something to that because it's sort of like you can now pull the deep learning models from online, right? That's like kind of the easy part. The hardest part is the data. I worked on like several projects, but it seems that it's usually coming up with the data and what to do with the data and how to like structure it so you can build like a pipeline to make some sort of like either like a small product that kind of works what you wanted to do. And I think that combination with like expert knowledge, it's one of the things that you can develop like a quick prototype.
Yeah. Yep.
And I also feel like we need people from all background, because maybe like there's some set of people who are good in like coding and that skills, but those experienced people know the problem space better. We might know like some execution and solution space, but we need like maximum overlap.
Yeah. Yeah. Yeah, of course. Those are very difficult problems. Yeah.
So one question I have is like, can you walk us through like how do you go about doing like a state of the art model like DALI? Like how do you start to implementation? Do you read research paper, watch YouTube videos? Like I just want to know the whole process.
How I started. I mean, first, I guess I read the paper and like the blogs. That doesn't help so much the first time. It's just like to see what's going on. And then the community. I mean, inside Discord, I didn't develop the code, right? Lucid Rains developed the code because OpenAI never open sourced the code. I was just there like watching it happen every single day. And I was one of the many like testing it. So we had like, we all of us had some data. Some people used like Imaginary, whatever. I used my own data and we were all sort of testing and giving feedback. Yeah, this works so well. This is good. This is bad, So that's how I went through to get like, how do I state of the art? It's just a good architectural DALI by being there while so it's really about like daily being there. So like you can't really do it if you just say, okay, I just do a couple of tests and see like, it needs to be something that you really integrate into, like you put a goal, right? So, and then after the discussion and stuff, you start become more comfortable and with the code, even though I think that's the last part, at least for now, if you are starting, but more importantly with the intuition behind the model, like why does it work, how can I change it, like for example, I would have never went from DALI to Architects if I hadn't understood what DALI does exactly, like so after I understood, I was like, okay, so I have these pieces, what if I take this piece out, so this is important, but it happens through, I think through the Discord for me, it happened. And through experimentation. It's really important to experiment for sure. So I had like a lot of tests, I think mostly because of my data, but also because of the early code, right? But so you need these iterations in a way, always. Yeah. I mean, I don't know if you wanted like code walkthrough or something like that. The code is very simple. Like if you go to to use it, right? You just give it a folder, like the code is super simple. There's just a folder with an image text, and you press the command and it works. And you could do it and it will work. And if you give it very clean data, you will have a nice DALI. I think my intuition is that if you give it very clean data, okay, you need also a VQ gun and stuff. Okay, but you can do it, what I did, like in very narrow domain. But it's better if you sort of understand it a bit, what it does. Once you do that, you can start changing it. Yeah.
I see. And I feel like you have some incredible ideas So I'm curious, like, are you open for collaboration? Because like there might be people who are interested in those ideas and want to develop and code together or something.
So yeah, for actual work, if I said yes, it would be very responsible of me, because like the time is like out to here, mostly because of like I already opened too many things in my mind,
I
right?
see.
But for like, like discussing ideas and projects, like, how to, and is this good? I'm always up for this sort of discussions like this. And yeah, if there is something I can actually help, like I know I can do efficiently, like let me do it for a couple, let me do it for you, and I said, yeah, for sure I can do that. But I think it's more, I would be way more helpful if I just sort of, discuss an idea. Yeah, maybe you look there, you take this, you do this. I can sort of guide in the things I've learned so far, if someone is interested, for sure. But actually doing a project, yes and no. Like, I don't know, it depends on the time, and if it's something that, because the other very important thing, and everyone knows this, is that you need to select what you care about, right? It cannot be anything. It cannot be eminist, like, or it needs to be. So yeah, so yeah, for sure. So reach out and I can discuss ideas and things. I can give any guidance if I have. I can even do better and send to other people who actually, might have even better guidance. All this stuff I'm open to.
Yeah, I really appreciate that. Like, thanks for being like
Sure.
mentoring us. Yeah.
Hey Theo,
I'm barely passing knowledge that I heard elsewhere. I don't know if that's mentoring, but if it is, it's good. Yeah. Sorry.
I just had a quick question. I guess we talked a lot about more like architecture related stuff, but what about in the urban like design domain or urban planning? Um, have you seen any applicability of these types of models, or is there like some sort of work that you're interested in?
Yeah, definitely. You can do urban design, like you can do urban text or whatever. You want to take the name, you can do that. Yeah. For example, it's just this. It's the same thing, right? What's the difference of a layout? Like again, a layout and a neighborhood is vastly different in terms of like architectural design, right? But in terms of language, they're not. Again, this is the beauty of language, is that you can describe things very efficiently. There is very rich, diverse, so like they're not. You can do the same thing for urban design. I don't know how it will come out. Maybe it will come out wild. And there are tricks you can also do to make it a bit more abstract. So one thing we didn't discuss in this stuff is that there is a level of abstractness, very little to very high, like, and you can play around with that. And the more abstract you are, maybe it's easier to generate things. So, but for sure, you can do all this stuff for urban design as well. Even DALI, you can do urban design for sure, and it has a place. And it has a place. I mean, I wouldn't do, usually my experiments for urban design is like make this neighborhood, which is not realistic. And okay, where I am, actually, they make neighborhoods, but usually you don't make like that, a whole city. But you could do like, similar like architects for a master plan very easily, or for a site. For a site, not so much, because how many buildings are in a site? Okay, maybe you do like 3 buildings. Like for a site, you can do a parametric model, right? It's not very difficult. But if you have like a small master plan, then you can do, right? Because there are a lot of interesting semantics that go in there. And also there are a lot of layers you can sort of add. Like maybe you do first like, building layer, then you do like landscape layer, like all this stuff. So yeah, it's definitely a possibility. It's something I haven't done yet, but it would fit very well with infrared, which, as I said, is an urban performance design tool in real time. So if you had a generator in real time, and actually something we are working, like ideally we are working in the future to have, so a good generator to link to infrared. So I think, yeah, it has potential.
Yeah.
Urban design.
Yeah.
But anything, sorry, but think of it anything, like urban layout, like, I don't know, facade, like, I don't know, a panel, like it can be anything. Sorry.
Yeah, no problem. Yeah, I was about to say, like, I'm yet to see like some ML model develop on top of multimodal data from like websites like Arch Daily, where they're like detailed info, like description. I think that's a reach. rich resource which we haven't exploited yet.
Yeah, yeah, we have a lot of metadata, I think. Yeah, we have a lot of cool stuff. And even Clip, like, I mean, the images, I don't want to abandon the images. I think Clip has a place. It's just that I think you need to have both in a way. Like, you can't just have only images, I feel. You can't only have just only language or text. So you need to have both, like multimodality. So I hope to go towards it. Like, there was a very nice paper by, I mean, it's Hinton is in the team, but it's not by him, right? But I think from his students or like PhDs, like the Pix to Sec, I don't know. So like that was really nice. Like in the sense, it's sort of the inverse of what the architects does. In a way, like it takes an image and it creates bounding boxes. So again, it finds bounding boxes of things from an image, and instead of doing convolution, it just does text. Right? It's really cool. Language again. But I could see that as a connection. Like you can go from language to design, and the design you can use like a bunch of software to visualize it, right? And you can use, and because if you make an image of that design, because your annotation is perfect to that image, you can train a model to do the reverse after. And then you can take that model in the wild and say, okay, what about this? You know, like, and you know, that might be interesting if you want to, like, I don't know, crawl, you know, websites and, you know, all these PDF layouts and stuff, right? So yeah, I think there's a lot of potential in sort of like interrelating the two. So I don't abandon images. It's just that initially, yeah, it's not so helpful initially. You need to avoid them a bit, yeah.
I'm just like exploding with ideas because like you mentioned about that. I thought it might be interesting that you have this text to design model, but if we like make a workflow where you get the output and then using, let's say, like Pix to Sec and some human manipulation, you get a text again back from that given output, and then you can compare like input text versus text generated and maybe like do some cosine similarity and like iteratively training to get like better output.
Yeah, exactly. Yeah. Yeah, you can train the reverse. I think it's good. The inverse, I would say, not the reverse. Yeah, there's a lot of things, and then it depends on what you on the tasks, right? Like maybe that's an interesting AI paper, but not very interesting design task, but it could be. So like it depends. Like I can't think of all the tasks. I can think of very few tasks because I'm still like developing this stuff, but I hope others will come up with tasks because that's the important. Even the AI research, I should say, it's all about tasks and also losses lately. But losses we don't need to do. Like it's very mathematical. That some other people can do. But the other part, I think, the most people focus is multitask learning. What kind of tasks, you know? And these tasks are like, for example, right? The most standard task in the mask learning model. You have a sentence, right? And you literally take away one of the words and you put mask in its place, right? And the model learns to find the word, right? It's very simple. And you can do that randomly. This word now, right? So how can you do that in design? Very easily. You have a design and you mask one space out of it, okay? And then you train the model to find out what that space was, right? Or you have a geometry and you mask some part of it out of it, and you want the model to complete it. So you can create like architectural tasks to train deep learning models. You know what I mean? Like design tasks. So all this stuff are really cool, I feel. And again, the people, you don't need, you know, to know like, you know, AI or all this stuff to do that. Yeah.
I see. And the language is particularly interesting because like their domain space is quite like less compared to like image space. Like they have like there's a set amount of words, so you know, like you could predict.
Actually, I think it's richer. The language is richer. Yeah. I mean, apart from the infinite almost combinations, is richer because like images have a lot of pixels, but not all pixels matter. That's why convolution works. So like there is a lot of correlation. While I think in language there is more diversity. I don't know. It's not really my field, but I would say language is harder. Like if you see the scaling laws paper, the one that tries to see, you know, how down can we go? They haven't reached like the lowest loss, but how low? Language, it's still like the highest of the losses. I think image is like 0.5 or 0.1, language is 1.2. So it's a bit harder domain, richer. But yeah, it depends, I guess, what you do in your task too. Like maybe, for example, in a task like layouts, I don't know actually. If you don't have any details, maybe they are equally not very rich, perhaps, because it's like a small domain, like changing stuff. If you put like, textures and materials and stuff, then the visual becomes more rich because you have like, a 2-bedroom house where, and then it's like, with different textures, different materials, but it's the same annotation. So it depends on your domain, I think. But generally language should be a bit richer, yeah.
I see. And is there anything which we didn't discuss in this interview you would like to share your thoughts?
So yeah, the last thing is I would ask people to check architects. So now, thankfully, I think I will post this like early this week. Thankfully, like Hugging Face was very good to provide like to link like a GPU on the space. Like it's still in beta, the spaces, but it's really cool. And people can try it out on the site. So the site is quite easy. I think it's architects.design and it's quite fast. Like for me, it takes a couple of seconds to create something. So what I would ask is like, please let me know how it is from the designer's point of view. Also like maybe, let me know the types of prompts. Like I really like seeing like screenshots, like people, a friend of mine like screenshot, look, this didn't work. And he had like, what did he put? Like a very large villa or something like people really like prompted with completely out of my distribution. So I want to see what types of prompts they want to build. That's quite interesting. Yeah. So yeah, if that would be nice.
Yeah.
Hey, Theo.
Feedback in a way. Yeah. So here in the top there is a generate layouts, and that should be quite fast. There is like some guidance in the bottom, I believe, like what to do, like, these are sort of like labels and stuff. But I don't care. Just like put anything. Like I would really want to see failure modes. Like, look, I put this, large villa with a courtyard and it didn't give me anything. Of course, it will never give a courtyard. There is not in the data, right? But those failure cases are interesting, I think.
Yeah, and also like I think Gradio has this option of flagging it, so also you could keep track of all the weird like layouts which didn't align.
Yeah. So, but I would say that this current model is quite good. Like if you stay close to the semantics, like the boring semantics I have right now, it works really good. Like it's really surprisingly good in a way. Yeah, so that would be nice.
Awesome. Yeah, I love this. Like this is an amazing development. And I know, like you mentioned briefly, that your next plan is to like add more performance-based functionality and like making it into a product. So that's interesting.
I mean, we will see. I mean, for now, like, it's important to, like, again, start simple, right? So for now, it's important. I just want to make it a demo, and I want people to use it everywhere, and see, what's missing, what needs to, like, all this stuff. Because again, it's both research and practice. So this feedback is important to see, like, which direction should these models take, these tasks, and all this stuff, and also, like, how can it be useful? Yeah. So that would be cool. Yeah. If people can let me know anywhere. Yeah, it would be nice. Or just post it somewhere. Yeah.
Awesome. So my last question of this interview is like, what are some things you recommend for people who want to like learn more about developing this kind of tools? And I mean in the sense of conference, books, webinars.
Okay, yeah, conference is a good one. Like, of course, you need to work on it, right? Like, you need to put time on it. The cool thing about one of the things that is really nice during lockdown and remote is that the conferences are very cheap. So, for example, I just registered for NeurIPS the other week, and I believe I paid, as a student, was it like $40? I forget, like ridiculously cheap. Like for me, it would have been like $10,000, if it's like I had to go there. And anyways, I would never get tickets, right? So I highly recommend like follow the big conferences. Even this $40 is enough. Even if you go like a couple of days and you see like a couple of talks is enough because you will get access after. But being there is nice. Maybe it inspires, right? So the conferences are cool, like all the ICML or NeurIPS, all these AI conferences. And books, not so much. I mean, there are some books about general, AI and stuff. That's what I would read. And then papers. And the most important, I think, is the communities. Just join a community. You can lurk is okay. You don't need to like. Not everyone, talks as much as I do in a way, but that's okay because maybe people just do stuff better. So you can lurk in the communities and you will learn a lot. Yeah, and then read some papers, find the thing that you care about. In a way.
And like one thing I feel very bad is like some of like this machine learning conferences like are very cheap. Like even like the top ones are like $100 or around that. And some of the AEC and like BIM or ACAI conference like $1,000 or
Yeah,
$2,000 and like
I know.
okay,
I know.
what
I
are
know.
we charging for? And those
Yeah.
were some of them were online, so I'm not sure how much logistics cost is being.
No, that's not a good view in a way of them, like yeah. But yeah, I mean maybe it's economies of scale. I don't know. Like, but in any case, yeah, go to NeurIPS like virtually because if you're a student, I think it's not even 100. I think it's like 40 or something, 50. I think it's totally worth it in a way, especially if you just say for 3 days I just stay here and I watch all of these things, because like in Europe, like especially the spotlights and the like the big keynotes, those are inspiring things. Like that's where I think people might find like hi, this sounds nice. I want to follow it. So that's totally worth it. Yeah.
Awesome. Thanks a lot, Theodore, for like being so honest and like sharing all of your knowledge with us. It was an amazing discourse. I learned a
No
lot.
problem. Thank you for having me. It was great. Yeah. And I hope the audience enjoyed it.
Yeah.
We need
Thank you.
another one.
Maybe after
Yeah. After I have maybe something new to add in a way, it would be nice. But yeah, we should do again.
yeah, some like part 2 of Archie test or urban test when that model
Yeah.
comes out.
Yeah, maybe. Yeah. Hopefully. Okay.